Good day, trainees. Maugarapo Matisa. Hello, welcome to my next video of forces, and this time around we are going to deal with Bose notation. Now remember, in the previous 3 videos, the first video we explained the forces, the basics of forces. The second video we took on parallelogram of forces, the one method, and in the third video I explained to you an alternative method of how to draw your parallelogram of forces. Now in this video we are going to concentrate on Bose notation. What is Bose notation? Well, this is a notation that we use to draw 3 forces. Now remember, in the previous section it was all about 2 given forces and we needed to draw it, and we needed to determine the resultant and the equilibrium. With Bose notation we are moving on and we are dealing with 3 forces that are in equilibrium. Now, these 3 forces that are in equilibrium, we say this is a triangle of forces. Remember that the previous one was parallelogram of forces. Now we are going to use a triangle. Its forces are very interesting because as we move along we keep using different shapes. So when you have 2 forces you think of a parallelogram. When you have 3 forces you think of a triangle of forces. Now the triangle of forces is defined, or the law states that when 3 forces are in equilibrium, their sides, the sides of the forces, the sizes of the forces can be, and the angles can be represented with the sides of a triangle, taking them in order, and that order can either be clockwise or anti-clockwise. So that is how we define a triangle of forces. Now when they say taken in order, you are not going to take one force and then you jump to the other one. We take them either clockwise, I repeat clockwise, or in a anti-clockwise direction. That is how we are going to take our forces. Okay, to continue, I've written down the definition of a triangle of forces, where I said when 3 forces are in equilibrium they can be represented in size by the 3 forces of a triangle taken in order. Remember, we are representing them in size and direction because our forces always have direction. Now the first example, says the 3 forces below are in equilibrium. Graphically, and remember graphically, if you say graphically it means you are going to draw. Graphically determine the magnitude, which is the size of the 2 unknown forces in the diagram, that is force L and force. This is a diagram with our forces. So we have 3 forces. We have a 90 Newton force that is a vertical force, and we have L and then M. Now this is our space diagram. if you refer to your textbook on page 94, it says, the Bose notation says, it's a notation that we use to letter our open spaces. Your open spaces are the spaces between your forces, and there will be 3 forces. Don't mind that, because this is just your direction line, or the line that divides your Cartesian plane. Remember, we have 4 directions, and we can indicate the other one here. So this is your north, east, south, and west. That is what the dotted lines are representing. But all in all, we have 3 spaces between the forces, because remember the forces are 3. Now, Bose notation says, if you read further, you'll find a paragraph that says, you letter your open spaces, either you can either move clockwise or anti-clockwise. But how do you do this? You start at the open space after the last unknown force and before the first known force. In this diagram, we have 2 unknown forces, that is L and M, and 1 known force, that is 90 newtons. So Bose says we must letter our diagram, our space diagram, this diagram, and we start at the space after the last unknown. Now let me show you. If you are going clockwise, let me say you start moving from the east, and then you are going clockwise. You find the first unknown, and then you find the second unknown, which is the last unknown that we have when we are moving, and then the first known will be the 90 newtons. So our A, you can take letters A, B, C, consecutive letters, or D, E, F, consecutive letters, but your first letter must start in the space, between the last unknown and the first known force, meaning our A will be here, our B will be there, and then our C will be in that space. So we have lettered our diagram. Now the next thing that you need to do is to determine the shape of your triangle. So the shape diagram helps you. It's a little diagram that you do not to scale, but it helps you to determine which shape will your triangle take, or how will you draw your triangle, and which side will the triangle face, all those things. Now if you are moving clockwise, if you are moving clockwise, we draw these forces head to tail, meaning the arrows will follow each other. Now if we are going to draw moving clockwise, we always start with the force that is known to us. This is the known force, 90. That is the 90 Newton force, and it faces up. The next force you are going to bring in is M, that you are going to draw. Now you need to determine what is my angle between, if this is 90, if you bring 90 down, is that line, what is the angle between 90 and M? That angle, what is the size of that angle? This is 30, and then the angle here is 90, so 90 minus 30 will give us 60 degrees. It means when you are going to draw, you measure an angle of 60 degrees up, and this will be your M with its arrow facing down. And then the force that you are going to draw here will be your L force. Now you also determine what is the angle between L and 90. That is this angle. So if this is 45, meaning that will also be 45 newtons, because degrees, because this is 45 degrees and these two angles are equal. So at this corner you will measure 45 degrees, and then you will draw your triangle. So L will be there with 45 degrees. If you decide you are going to move anti-clockwise, this is for those that are going to draw anti-clockwise. You start with your 90 newtons, still the known force, and then you are going to bring in L this time, because L is the one that is after 90 if you move anti-clockwise. So L will come up there, because remember your arrows must follow each other. L will come here, and you already know that your angle between L and 90 is 45 degrees, so this will be L. Your M, you are going to measure it at the corner down at the end of 90, but down this time, and that will be your M, and your angle will be 60 degrees. So you can see the difference between the two triangles. This one will face on the other side, while this one will face on the left side. This one will face right, this one will face left, and you will see that the forces move with their angles. M, the line is up in this triangle on the right, but in the angle 60 will be up. When M moves down, your angle also moves down. L in this triangle on the left is up, and its angle is 45. It will also be up. In this one, L will come down with its angle of 45. So we do not change the size of the forces, and we do not change the angles of the forces. So those are your shape diagrams. From here we are going to do the vector diagram, and it will be easy because we already know the shape, we already know which direction our triangle will face, and we have already determined our angles for our forces. So we can proceed to drawing our vector diagram or our force diagram. And remember, this is a diagram that is to scale, and we are measuring it because we need to determine the correct sizes of the forces L and M. Alright, let's continue and draw our vector diagram, which is also our force diagram. I've written down the scales for you. You can choose any that you prefer. Now we are going to draw both shapes. We are first going to draw the one which we are moving anti-clockwise, and then we can draw the one where we are moving the clockwise direction. So we start. Remember, we already have the shapes that we did few seconds ago. Okay, now we start by drawing our 90 Newton force. Please make a straight line. The 90 Newton must be a vertical line. Please try by all means to make it a 90. It must be to an angle of 90. It must be very straight. This will eliminate the errors of either increasing your forces, the answers that you get. So make sure the 90 Newton is vertical, 90 degrees. Okay, make sure you label your arrow, so with your arrow the direction, and then you indicate that that is your 90 Newton. Now if you look back, on our space diagram, you will see that your line 90 is AB. M will be B, C, and then L will be C, A, moving clockwise. AB, BC, and then CA. It will be the same. If you move anti-clockwise, it's PA, your line BA or AB, AC, and then CB. It's the same. And that is made possible by the lettering according to Bow's notation. All right, we continue. So this is our line AB. That is our line AB. Then we are going to measure the angle. We say the angle of M is 60 and the angle of L is 45. And remember, we are on the clockwise, so this one here. You see, your angle of M is 60, your L is 60, so you are going to measure 45. Place your protractor there, and then you measure 45 degrees inside. 45 will be there. You bring your protractor down, and then you measure your 60-degree angle. So those are your two marks, and we can draw our lines that joins to the 90 Newton force. That is your first line that joins to them. That is your first line that joins to the 90 Newton force. And then this is the line of L that joins to the 90 Newton force. The good thing about the two lines is, so your point C will be there. The two lines, the M and the L, you do not know their sizes because we are drawing to determine their sizes, the sizes of the forces. So it means when you join them to 90 newtons, you just extend the line, and then they will cut or they will cross at the point where they will stop. That is your point C. So that is C, and this is M, this is L. You will see my arrows are following each other. head to tail, my angles are as we determine them, and you will see that I did not change the direction of any forces. The forces have their direction as they are on the space diagram. Now let's draw the second shape. That is your second shape for your triangle if you are going clockwise direction. Now we again start with our 90 Newton. I apologize for the blinking and the blaring of the video. Don't know, it's maybe the movement that is too much. Okay, so we start again off with our 90. That is our 90 Newton line. Then you measure your two angles. You measure 60 up because this time M moves up, so this is 60, and then we measure our 45 down because L is now down or below. Then you join your lines. You see how easy it is if you have determined your angles in the shape diagram. It becomes very easy. It will take you 1 minute, 2 minutes to draw your diagram, your triangle. So you label it correctly. This is your 45 degrees. This one will be L. This is M. Sorry for that. Okay, it looks, let me just put it properly. M. This is your 60 degrees. This is A, B. That is your point C. So there we have our second shape. This is the shape you get if you take the anti-clockwise direction. This is the shape you get if you take the clockwise direction. Okay, now coming to our answers. So let's write down here our solution. Now you are going back to your diagram, and then you are going to measure L and M. So if I start, okay, let me start with L, and then I will measure M. I'm using the 1-to-1 scale or the 10-to-10. It's all the same. Okay, so I go to M. There is my size of M. If you go, I hope you are finding your sizes, you are reading off the correct sizes. That is the size of M again. So on both diagrams, I am getting that my M is 67 newtons. I hope you have also measured 67 newtons. And if I measure my L on the first diagram gives me 81, and that is the same 81 on the second diagram. So for L I have 81 newtons. So now remember with this, if you're accurate, your answers must be, when you are drawing, please try to draw such that your answers are within plus minus 1 of the exact answer. What do I mean? Your answers must be in that range. Meaning, if it's 81, the acceptable answers will be, for 81, your acceptable answers will be 80 newtons, 81, and then 82. So it's plus 1 and minus 1. For 67, it means your answers must be within the range of 66, 67, and then 68 newtons, plus minus 1. To achieve this, please make sure you measure your angles properly. Measure your angles accurately, and your lines, you must measure them accurately. Also, you must draw with a sharp pencil. Make sure you are drawing with a sharp pencil. Also, be in a comfortable position. Do not move too much when you are drawing, when you are making your drawing, or your lines will be skew, and it can increase or decrease your lines and your angles. Also, the other thing is, just when you are making your drawing, please label your diagram correctly. So these are things that you need to take into consideration when you are doing your diagram of your forces, and make sure you use a suitable scale. To also make sure you eliminate, if you use a scale that is too small, it will not be very comfortable. Okay, I'm leaving you with an exercise to complete. Exercise 1. The instruction is graphically determine the size of the unknown forces in the following diagrams. This diagram A, and then diagram B is below. I'll show it to you now. Now, in the first diagram, this is 150. That angle is 150 degrees, and then you have a 90 degrees. You have a 1000 Newton force, and the unknown forces are P and Q, and the scale, I gave you a hint to use a scale of 1 millimeter equals to 10 newtons. So we have a bit of calculations to do there. For the second diagram, you have a load that is hanged to the roof. Your load is 60 kilograms, and then you have the forces of S and T. The two ropes that support the load is S and then T, while the load itself is 60 kilograms. And then you are given that the angle between the two ropes is 75 degrees. So after you have completed your exercise, you will find the answers in a Word document or a PDF document that I will upload just after this video. Please do check out your answers once you are done. Thank you for listening, and for watching. Please leave your comments and then the questions in the discussion forum, or you can write to me privately on the e-learning platform.